Okay, guys, hello. So I hope I'm audible. One of you can unmute and just respond.
Yes, sir.
Okay, that's great. So we'll wait a couple of more minutes, right? And then we'll start in a couple of minutes. We'll wait for others to join if there are more to join, and then we'll start. Okay, guys, hello everyone. So I think we should commence now. Reasonable number of people are on the platform. So today we'll be discussing assignment number two, which was rolled out the previous year, right? And again, this is Aditya, and I'm a PhD student at IIT Bombay, and I'm here to discuss and clarify your doubts regarding assignment number two. So yeah, I forgot to join using my mobile. Just allow me to join using my mobile as well. Yeah. Uh, so let me share my screen now. I hope the screen is visible as well. So this is question number one, right, guys? So this is question number one. In this, the question asks you to figure out the value of the current which is flowing through the resistor 28 ohms, right? So any guesses how we are going to proceed forward? Feel free to express yourself. Just unmute yourself and then tell me what how you're going to approach this problem in the simplest manner. So again, for those who are joining just now, this is question number one, and the question asks you to find the value of the current which is flowing through 28 ohms. My question to you is how in what's the easiest way to figure out what's the current flowing through 28 ohms, or how we are going to figure out the current which is flowing through 28 ohms? Okay, since none of you are responding, maybe this is the first question of the session, and then you guys are not in the mood. So let me talk about the different methods of figuring out the current which is flowing here, right? So the first can be use of superposition theorem. Okay. What's the other way? What's the other way of figuring out the current through this 28 ohm resistance? What can be the other way around? Okay. Please,
Sir,
please
nodal
respond.
analysis.
Good. Nodal analysis. What can be the other way? Feel free to pitch in, guys. So what you are going to do at nodal using nodal analysis, you are going to take this node and you are going to figure out the current which is flowing in and out of these two nodes, node A and node B, right?
Yes, sir.
Right, that's great. And the third method can be, how about use of Norton's theorem? You all of you have studied Norton's theorem, I'm supposing, right? Right? You have been introduced to Norton's theorem, right? Please respond, guys. It would be helpful if you are responding. Simple yes or no would be great. Right. I am asking, have you guys been introduced to Norton's and Thevenin's theorem? A simple yes or no would be great, guys.
No,
Okay.
sir.
Okay. So there is something called Norton's and Thevenin's theorem. Maybe you will be introduced to these things later in the course, so I'll not delve into these. I'm hopeful that you have been taught nodal analysis, right? Because one of your colleagues has responded. And have you been introduced to superposition theorem?
No, sir.
No superposition theorem, no nodal analysis. Okay. And how about KVL, right? Mesh equation you can write, right? Mesh equations.
Yes, sir. Yes,
Yes,
sir.
sir. KVL and
Okay.
KCL.
Right. KCL and KVL you can write. That's good. Uh, okay. So actually there are five approaches by which you can solve any electrical circuit here. The first one is superposition. The second one is nodal analysis. So you have not been taught this. You have not been taught this. And you have been taught this, you have been taught this. So in total there are five methods of solving this particular question. Now the simplest could have been use the superposition theorem, but then since you have not been taught that, the other simpler things could have been use of Norton's theorem to solve this, but you have not been taught that as well. So we'll go to the next simplest one, that is the nodal analysis, right? So let me try to solve this problem using nodal analysis. So I'm considering node A, right? And I'm writing the equation for node A, right? So node A is VA, right? So and I'm considering this to be the ground right here. So this will be VA minus VB by 28 plus VA by 4 is equals to 10, right? The second equation can be VA minus VB by 28 plus VB by 8 is equals to 5. Any queries how I got these two equations?
No, sir. No, sir.
It's obvious, right? I'm trying to figure out the current which is flowing in here, and in here, and then I'm writing the equation number 1, right? So the sum of the current which is flowing in must be equal to the sum of the equal to the total sum of the current which is flowing out. So the current which is flowing out is only in this branch, right? So that is
That means,
equals,
sir, incoming current is equals to outgoing current. Am I right, sir?
correct, you are right. So, I've shown the directions to be a little wrong here, right? Because the directions is actually, if you'll see the equation number one, uh, the current direction here in this branch should be like this, right? Because the current is flowing out and this current is coming in. So for equation number one, it is the 10 ampere current is coming in, right? And these two currents are flowing out, right? These two currents are flowing out. So that gives you equation number one. Equation number two is also the same. The current is flowing in from this direction. So this is the current value. And I'm supposing that this current is flowing in and this current is flowing out. So this also must be flowing in like this. Then it will be the same sign will be held. So this here is a little wrong here. This will be minus. So did you understand, guys, what I'm doing here?
Yes, sir.
All right. So you have got two equations. You have got two variables. You can solve them to figure out the value of VA and VB. Correct?
Yes, sir.
Any problems there? No problems. Good. So all you need to do is you multiply it with your with the 28, value of 28, right? Because it will then cancel out. And you can also multiply this by 28, right? And add these two things together, right? So it will be the equation one will be reduced to simpler form of VA minus VB plus 7 times of VB is equals to 280, right? And this will give you VA plus 6 VB is equals to 280, right? The second equation will give you VA minus VB. Okay, this was 8, right? So you cannot multiply it by, if you're multiplying it by 7 4s are 28. So 28, it will not go in 28, right? This is not the LCM of 28. So second equation will give you 7 by 2 VB is equals to 28 into 5 is 0330. Correct? Correct, guys? So let me know if I'm making mistakes here, right?
Sir,
In writing
140. Sir, 140.
140.
140,
Okay.
sir. Yes, sir.
And then this will give you VA minus 1.5 VB is equals to 140. So you have two simple equations, right? Here, equation number 3 reduced form and equation number 4 here, right? Now you can subtract the 4 from 3 and you will get 8.5. 8.5 VB is equals to 140. So VB is nothing but 140 divided by 8.5. And similarly, you can figure out the value of VA. So guys, if you are having a calculator or something like that, please feel free to calculate here, right? And tell me the answer. Do I have a calculator with me? Yeah. So 140 divided by 8.5 is 16.4. 280 by 17. And similarly, VA can be evaluated as 280 minus 280 by 17 So this minus 280 by 17 divided by 28. Okay, I have done some mistake here, it seems. So apparently I have done some mistake because I'm not getting the value as 2, but then this is how you are going to figure it out. Uh, did you guys follow the process here? And if yes, can you spot where I have made the mistake here? Guys, 8.5. Okay, 280 minus answer divided by 6. Okay, so this is VA, right? VA minus 140 divided by 8.5 divided by 28. Okay, I made some mistakes here. Okay, nonetheless, did you guys follow the process?
Yes, sir.
Yes, sir.
Okay,
Yes, sir.
the process will remain the same, right? I've made some mistakes in multiplication and addition, it seems. So the process will remain the same. You have to figure out the equation at node A and node B, right? And then figure out from there the value of VA and VB. You have to subtract VA and VB and then divide it by 28 to figure out the value of the current which is flowing in here, right? So if that is clear to you, let me talk about one more technique, which I'm very sure would be useful to you guys. So let's suppose this was only two equation system, right? And let's suppose you have some n number of equations, right? Let's suppose you have some a1 x1 plus a2 x2 plus a3 x3 so on up to an xn is equals to b1, right? And then similarly you have a I should have written here instead of so here will be a2 x1 plus or not a2, this will be 1 1 1 1. So superscript 1 for the first equation and subscript 1 for the letter here. So a1 a2 2x2 plus a3 2x3 so on up to an 2xn xn is equals to b2, right? So on up to nth equation, right? So an 1 xn x1 plus a2 n x2 plus a3 n x3 so on up to an n xn is equals to bn, right? So I have a n linearly independent equation and I have to figure out the value of each of these x. So what's the method you are going to use to figure out x? First tell me, is this system of equation possible in nodal analysis and mesh analysis, right? You commonly see these kinds of equation, right?
Yes, sir.
Right. So suppose you have 4 equation and 4 variables, right? Or 3 equation and 3 variables. Here also you can get those equations, right? So if you'll write the mesh analysis, you will take this current as I1, you'll take this current as I2, you'll take this current as I3, right? So I've taught you one method that was nodal analysis in the previous section. I can also write a mesh equation here, right? So I'll have one independent equation using this, second using this, third using this. Let me just write the equation for the sake of argument here, right? So let the potential across this point be equal to V1, right? So I'll write V1 minus current I1 into 1 ampere, 1 ohm is 1, right? And then through 4 ohms will be minus I1 minus I2, right, into 4 is equals to 0, correct? This is equation number 1. Equation number 2 can be, I'll write this mesh equation for equation number 2. It will be minus I2 minus I1 into 4 ohms, right? And minus I2 into 28 ohms, right? And then across these 2 points, I'll say the potential is equals to across these 2 points, the potential is equals to V2. So I'll just say is equals to V2 or minus V2 is equals to 0, correct? And the third equation, third mesh equation, I can write it as V2.
Sorry to disturb you, sir.
Right.
Sir, my question is that there is a current going to be 10 ampere in loop 1,
Right,
I1.
right.
So instead of I1, we can write it simply as a 10 ampere.
Right. So I'll come to that. I'll come to that very shortly. I'll come to that very shortly.
Okay, sir.
Right. So in the third mesh, so I'm just going step by step here. Instead of assigning a value, I'm just doing step by step here, right? So there will be 5 equations or 4, I don't know, at the end of the thing, right? So the third mesh equation, I can write the voltage across this 5 ampere thing is V2. So V2 minus I3 I have nominated, right? So I3 into 8 ohms is equals to 0, right? Now we see we have 3 equations and 5 variables here, including V1 and V2. So we know we need two more things, right? So from mesh number 1, it is obvious that I1 is equals to 10 amperes, right? So that is clear. And then what else is what else you can say? You can also say that I2 minus I3 is equals to 5 amperes, correct? So in total, we have now 5 equations, right? And 5 variables. Or you can say 4 equations, 4 variables, because this is simply evident to you that I1 is equals to 10 amperes, right? So no big deal here. So you can solve these 4 equations using your basic algebra and then figure out the value of each of these variables. Or you can use something which is which you might have studied in your higher education in your class 12, something called as Cramer's rule. Have you guys heard of it? Cramer's rule in matrices?
Yes, sir.
Cramer's rule. So try to remember it. If you guys have forgotten it, just try to revisit, and then it will freshen up your memory. So if you have got system of n linearly independent equation and you have got n variables, right? So n linearly independent equations, n equations, and n variables, right? In that case, you can use Cramer's rule. Now, what does it say? It says that the value of x1 will be equal to the determinant of B1, B2, so on up to Bn, and then the rest of these things will follow. A2, A2, 1, A2, 2, A2, so on up to A2n. This is terrible, I have to, right? And this will continue on till an1, an2, so on up to an, right? And divided by the determinant of this particular left hand side, right? So it will be nothing but a1, 1, so on up to an, n, and a a2, 1, so on up to an, n, a2n, and an1, so on up to an, right? So this is the generalized form of figuring out x1, right? If you have to figure out x2, how would you proceed? One of you tell me. You understood the method, right? All you have to do is replace this particular column over here, right? You have this determinant, right, of the determinant of this entire set of variables over here, right? A1 to an1, right? Superscript 1, and then you have the a column on the right hand side of b1 to bn, right? So when you want to figure out, let's say a variable x1, then you substitute the first column. You substitute the first column with this particular b's, right? And keep the remaining things same, right? This is what Cramer's rule says, and you divide the entire thing by the determinant of these particular elements. So maybe I'm not coming across, like you guys are not responsive. So let me just keep it. So if I have, let's say, 2x1 plus 3x2 is equals to 5, and if I have 4x1 plus 9, oh okay, not 9, 9x2 plus 10. So is this linearly independent or not? Tell me. Is these two equations linearly independent? Are these two equations linearly independent? So you have studied linearly independent equation, right? I'm supposing. Okay. I'm taking it for that for a yes, right? Because like I think if you have two equations with you, right, and you have, let's say, ax plus by is equals to c, and then you multiply it with some same scalar, right, lambda, then you will get a lambda x plus b lambda y is equals to c lambda, right? Now equation number 1 is not linearly independent with 2 because you don't have any new equations here. So you cannot solve for x and y, right? But if you have, say, let's say some gamma times x plus b lambda y is equals to c lambda, now you can solve for x and y. So now you have two linearly independent equations, right? So this is the meaning of linear independent. You can solve for the variables involved over there, right? Those are not collinear lines. Those are not parallel lines, right? You cannot solve the equation for, you cannot have a solution for two parallel lines. There are no intersections, right? So this is what is implied by linearly independent equation, that the equations will always have a solution, right? Am I clear to you guys? Do you understand now the meaning of linearly independent equation?
Yes, sir. Yes, sir.
Good. So you have a system of equation given by equation number 1 and equation number 2. My question to you is this linearly independent or not? Tell me now. Are these two lines parallel to each other?
No, sir. No.
Right. These two lines are not parallel to each other. But what if it was some 6? Would it then be a parallel line?
Yes, sir.
Okay. 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 So let me just write what was the value initially. 9, right? So how do you figure out the value of x1 and x2?
Sir, we can solve with the help of matrix point of view also, no?
Right. So tell me, how would you solve it?
Means it is by 2 matrix 2,
Right.
3, 4, 9.
Right. So x1 is nothing but x1, that is again given by Kramer's rule. So x1
Yes.
is nothing but 2, 3, 4, 9. Right?
Yes.
And
Yes.
x2 will be given as
X2 is given as 5. It is given as 5, 4, 2, 4, 5, 10, and similar 2, 4, 3, 9. Yes.
so. This is just a redundancy of the generalized thing which I had written in the previous page. There I had written nth order, sorry, not nth order. I had written n independent equations with n variables in it, right? And here I have two equations with two independent equations with two variables in it, right? So what you need to do is you just need to swap these column over here, right? In this particular variables, right? So if you want to solve for x1, you just put the column 5, 10 over here, and then you divide it with the determinant, which will remain constant for all these variables. That is 2, 3, 4, 9, right? 2, 3, 4, 9. This is just for example. And then you can get the values of x1 and x2. Similarly, if you had 3 variable system as you had here, or 4 variable system as you had here. So here it was a 4 variable system, right? So this was I1, I2, I3 was 3 variables, V1 was another variable, and V2 was another variable. But then I had said that I1 is equals to 10, so you had 5 equations to start with, but I fixed the value of 1 variable, so you are now left with 4 variables and 4 independent equations. You can use the Kramer's rule to figure out these particular variables. Now this might seem trivial to you in this particular case, but as you progress along in your studies, you will have big matrices, right, and big equations to solve. These types of mathematical solutions, mathematical approaches can make your life very easy. So, so my advice to you is, and this is so what I have taught you here is Kramer's rule, and Kramer's rule is a part of matrices. Matrices, you guys will be introduced to matrices in the mathematics course called linear algebra, right? So if you guys have forgotten, I am very sure that you will be again be introduced in your regular lectures, linear algebra, and there again you can revisit the Kramer's rule and then figure out how things goes on from there, right? So I hope I've spent enough time and everything is clear now. Let me just go on to question number 2 now, right? So any queries in question number 1?
No, sir. No.
Okay. So question number 2 is find the output V output that can be written in terms of V. So you have to figure out the voltage V naught in terms of V. So how would you figure it out? It's a very easy question, right? How would you figure it out? You have two resistance, let's suppose. Always try to break things up into smaller things, right? If you are not comfortable with the idea of one big thing, right? So I can figure out what the potential across the Rx term, right? In terms of the input V naught, right? What is the potential across Rx here in the new circuit I have drawn? Tell me. Vrx is nothing but Rx over Rx plus R1 into V naught, right? I can write like this, right? Simple resistance divider, voltage divider circuit. Is it obvious to you guys? Please respond. It would be helpful if you are responding. Okay, have you guys been introduced to voltage division? Okay, it seems no. So you can write the equation over here. You can write that I current is equals to V naught upon R1 plus Rx, correct? You can write this, right? And then you can write what is the potential for Rx? It will be nothing but the current I into Rx, correct? This is the potential for Vrx, correct? And therefore you can write Vrx is equals to Rx upon Rx plus R1 into V naught, right? I have done nothing. I have just taken equation number 1, equation number 2, and I have used equation number 1 and 2 to figure out this particular Rx, equation number 3. So is there any problem here in the understanding of 1, 2 and 3? Guys, respond please, because if you are not responding, I'll not be able to understand whether you are understanding or not. You are from a very diverse background and it would be helpful if you are responding. So all of you are from different colleges, right? Some of you might have been taught something, some of you might not have been taught something. So that's why I'm asking you again, like have you guys been introduced to these kinds of voltage divider circuit? Something like this? Okay, just let me call out someone and then okay. So Prashant Pawar, are you here, Prashant?
Yes, sir. Yes, sir.
So have you been taught a voltage divider circuit in your classroom?
Sir, actually, I've forgotten that thing. That's why I've been quiet for some time. I have
All,
been thinking on that.
all right, all right, all right. So did you understand? Like, can you see the screen now, Prashant?
Yes, sir. Yes, sir.
Okay, so what I have done is I have figured out the current flowing in this particular branch. Can you see that, Prashant?
Yes, sir. Yes, sir.
So what will be the value of current? Current will be equal to V naught divided by what? The resistance, right? Current is equals to
Okay.
voltage divided by resistance. Understood that? That is clear to you? Ohm's law?
Yes, yes. I
Okay,
is equals to V divided by R.
right. So what is V?
Mm.
V naught.
Yes, this I is equals to V0 divided by R1 plus Rx.
Correct. So that is the current I, right? Now I am asking you what is the potential across the resistance Rx? How would you figure that out, Prashant? current into resistance is the voltage across it, right?
Yes, yes. Means we
Right,
have to calculate voltage across Rx.
right. So how would you do that?
Simply again we have to be apply for the Ohm's law.
Right.
Uh,
So it will be the current
V is
I, V will be equal to the current I into the resistance Rx, correct?
Rx is equals to V Rx. Yes, sir. Yes, sir.
Correct. So that will give you equation number two. This is what I've written. Equation number two is Ohm's law basically, right?
Okay.
Now you can
Okay.
use equation number one and equation number two to get equation number three, right?
Okay.
Because the current, I have just substituted the value of current. Current is what? V naught upon R1 plus Rx, right?
Okay.
And then you're
So
multiplying it with Rx to get the value of Vrx, correct?
okay. Means we have to be put the value of I in equation number 2,
Right. To get equation number
3.
right? Equation, and what is equation number 3? It is the potential across the term Rx, right?
Rx. Okay.
But what is Rx? Rx is nothing but a parallel connection of R2 and RL, correct?
Parallel connection of sir
R2
R2
and RL,
REN. Yes, 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 yes,
correct? So I
yes.
can write Rx to be equal to R2 parallel
Plus
RL,
parallel with
correct?
RL. Yes, yes.
And if I'll substitute, and the potential across RL is going to be the same as the potential across R2 because both are
R2.
in
Yes,
parallel,
yes,
right?
yes, yes.
So if
So
I'll
it
substitute
is
this particular term here, what I'll get? I'll get the potential across RL, right?
yes,
Because Rx is nothing but the parallel connection of this, and we have understood that the potential across any one of them is the potential across the other, correct? So you will have something like R2 parallel RL upon R2 parallel RL plus R1 into V naught is equals to Vrx, correct?
VRX. Yes, yes,
So figure that out in these particular set of equation. That is evident from here. It's case D, right? Because R2
yes,
parallel
yes,
RL is this thing, right? And R2
yes, yes,
parallel R1 plus R2 parallel R1 is this one plus R1 is here, and that multiplied with. So case D is the answer, correct?
yes, 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 sir.
So my one piece of advice for you guys is practice a lot of questions, right? Because if you're not practicing questions, you'll not be able to pick and choose what to apply when, right? And also, if you're solving equation, you will be able to few errors which you are making, mathematical errors you are making, you'll be able to solve those things, identify those things, and then not commit those errors, right? Because you will have like objective questions will be coming in your future competitive examination, in where in you will have A answer will be -3, B will be +3, right? And a simple mathematical error will land you up at 3, whereas the correct answer was -3. So try to solve as many questions as you can, and then you will be able to identify where to apply mesh analysis, where to apply nodal analysis, where to apply case nodal is here, where to apply superposition theorem, where to apply what, right? So in this particular question number 3, let's come to question number 3. We are running short of time now. Uh, Tell me how we are going to solve this question. Is this a balanced Wheatstone bridge? Have you heard of the term Wheatstone? I can name this as R1, R2, R3, R4. What will happen if I have R1, R1 by R3 is equals to R2 by R4. What will happen? Have you seen these kinds of equation ever in your class 12th and class 11th, or even your first year undergraduate program which is running now? Uh, Simple yes and no can be great, guys. Okay, let me call somebody else now. Atif Patil, Atharv Patil, are you here now? Atharv,
Yes, sir.
have you been introduced to Wheatstone Bridge in your classroom? Atharv, have you been taught Wheatstone Bridge ever?
Yes, sir.
You have been taught Wheatstone Bridge, Atharv? Okay. Uh, so can you recognize what is is this particular circuit Wheatstone balanced bridge or not? Atharv? Okay, maybe I'll help you out here,
Sir,
Atharv.
sir, excuse me, sir.
Right.
Hello, excuse me, sir.
Yes, yes, please go on.
Sir, yeah, the question is regarding that we had to calculate the current
Right.
in the given circuit.
Correct.
So, is it possible that with the help of Wheatstone bridge, the concept of Wheatstone bridge, can we calculate the value of current in this
Right.
circuit?
Right. It's very much possible.
Okay, okay. Because I'm little bit confused about that. So let me clarify from your side, sir.
Okay, please feel free to voice your opinion. So
Because
if
I'm little bit
okay,
confused about
okay,
Wheatstone
okay,
bridge.
okay. So how do you solve a circuit?
Simply I use the mesh analysis again, KCL.
Right. But then you are right. You can use a KCL and then you can solve it. I would have done the same if you are not if I was not aware of Wheatstone bridge. So let me tell you about the Wheatstone bridge and I'll solve it by mesh analysis as well. So what Wheatstone bridge says is that if the system is balanced, if this equation is being followed, right, which is the present case here, right, this is equals to 2 by 3, right? R1 by R3 is equals to 2 by 3 and R2 by R4 is also 2 by 3, right? Am I right here, guys? So in this condition, no current is going to flow in here because the potential over here and potential over here is going to be the same, and therefore no current is going to flow here. So that is the basic idea. So you can basically remove this from the circuit. So you will have a very simple circuit of like this: 2 ohm, 4 ohm, 3 ohm, 6 ohm. So 6 ohm, and then it will connect it to 36 volts. So so 4 plus 2 is 6 and 6 plus 3 is 9. So you have 6 ohm and 9 ohm in parallel. This will give you 2 and 5, correct? And the current I will be equal to voltage divided by 9 into 2 into 5. So this is nothing but 10. So current flowing here will be equal to 10 amperes. So did you understand this? This is nothing but algebraic solution. But the basic idea of reducing this complicated circuit into a simpler form, right? What I have done here is that I have said that these two branches ratio are same, right? Therefore, no current will flow in this, right? And if no current flows here, you can actually remove that from the circuit. Now you will be left with a simpler electrical circuit of 2 ohm and 4 ohm, right? And 3 ohm and 6 ohm. And you can just add them up together because these are connected in series, these are connected in series, and these two are connected in parallel. So you can do some simple series and parallel addition, and then you can figure out the total equivalent R equivalent. So that is given over here, right? And once you have the R equivalent, you can figure out the I which will be flowing through this R equivalent, which is nothing but what is required by the question. So am I clear over here? Let's suppose you are introduced to these Wheatstone bridge in your future class, which I'm very sure the professor is going to do so. If you have not already studied that, then is it obvious to you that how do you solve it? So the last time I think Prashant asked, right? You had a query regarding this, right, Prashant? Somebody had a query here, right?
Sir, the queries about the Wheatstone bridge is that there is a 5 ohm resistance is to be connected in between that two loop. So the voltage is to be, as per your point of view, that the voltage is to be 0 in that case.
No. Across the 5 ohm it will be 0, right? Across voltage
Across
difference.
the 5 ohm is to be 0.
Right.
Sir, let me
That
know
is-
why it is so.
Right. So that is because you are deriving that when you will derive the circuit for Wheatstone bridge, you will use the mesh analysis, right? If you are not aware of Wheatstone bridge, you will use the mesh analysis. This is a simplicity which people have observed and they have taken into consideration. So what people have done is that they have taken this and then they have written down the mesh equation, right? They have figured out the potential of V1 and V2, and then they have figured out under what condition V1 is equals to V2. And that condition turns out to be when R1 by R2 is equals to, or R1 by R3 is equals to R2 by R4. So you do the same thing. You do the mesh analysis over here, and then you figure out the condition under which V1 will be equal to V2. You will come up with this particular end case, right? And if you have this end case, that implies that no current is flowing in this particular circuit, right? If V1 is equals to V2. So you can simply remove that. So this is how you proceed. So what engineers have done is just they have simplified the just to simplify the calculation analysis, they have taken the special case and they have made it a kind of a Wheatstone bridge kind of a concept, right? You would also be seeing this in your like first year. You will be doing some experiments in your lab, right? Where you will be seeing some deflection in the galvanometer. I've forgotten that, but then I think it's a part of first year instrumentation lab, where you will be introduced to these Wheatstone bridge. So don't worry, if you are not aware of Wheatstone bridge, you will be introduced it to you again. Also, you do the mesh analysis. You do the mesh analysis, so you'll write the equation as let me write the let me write the equation here, right? So I can write so I can write. So only 5 minutes are left, guys. So let me just. So this was given to you, right? 2 ohms is given to you, 5 ohm is given to you, then this is given to you as 3 ohms, this is given to you as 4 ohms and 6 ohms, right? And you are connected here to 36 volt. You are required to form IS, right? This is what you have asked to do. So one thing which you could have done is you could have taken this thing as instead of 36 volt, you could have taken this as 1 volt, right? This is how you are doing it. Like you use unitary method. So you will say that IS will be equal to 1 volt upon R equivalent, right? and then you will say IS1, and therefore IS will be equal to 36 volt divided by R equivalent. So why did you choose 1? Just to simplify calculations. The voltage can be anything random, right? So you use the unitary method and then you figure out what is the R equivalent for a unit voltage, and then the R equivalent will remain the same. So you do it for the 36 volt and then figure it out. So I'll quickly write the equation. Just tell me if you are following it. So the potential here is 1 volt now, the new potential according to the unitary method. So I can write the current which is flowing over here as 1 minus V1. I am taking this as V1, V2. So 1 minus V1 by 2 plus 1 minus V2 by 3 is equals to the current I, the current which is flowing over here, I, right? And then I can write 1 minus V1 by 2 plus or equals to V1 minus V2 by 5 plus V1 by 4. So this is for this particular node. So 1 minus V1 is the current which is coming here, and equal to the current which is going out. So current which is going out is this. So V1 minus V2 by 5 and V1 by 4, right? Because this is grounded, right? So or this is connected to the negative potential which is 0, right? And the third equation can be from the third node, right? From here. So I can write V1 by 4 sorry, third equation will be from here, right? So V1 by 4 and plus V2 by 6 is equals to the same current which is exiting out, right? So current which is going in will come out. So current is coming out. So again you have 3 equations, right? And the 3 variables with you are the current I, V1 and V2, right? These are the 3 equations and 3 variables. You can solve them, right? So again I can create a, let's say I have created a matrix, so I'll just write it down. So 3, 2, 6, 19, minus 4, 0, 3, 2, minus 12, right? And then V1, V2, current I is equals to 5, 20 and 0. Now you have to figure out the value of the current I. So for current I, what you will do is you will take the determinant 5, 20, 0, 2 minus 4, 2, 6, 0, 12, and then divide it with the determinant over here. 3, 2, 6, 19 minus 4, 0, and then the bottom row will be equal to 3, 2, and minus 12, right? So this will come up to this will come up as the current which is flowing in this particular circuit. And once you have this value of current, you can take the R equivalent to be 1 by I, correct? And once you have this R equivalent, you can then figure out what is the IS which will be actually flowing. That will be equal to this R equivalent, 36 divided by this R equivalent. So I have done this calculation, so I know that I will be coming in as 3.6, right? 3.6 ampere it will be coming. Therefore, R equivalent will be equal to 1 by 3.6, right? And then you can divide this particular thing, right? Like I wrote here by mistake. The current I will be 1 divided by 3.6. So the R equivalent will be equal to 3.6. and therefore the current I will be equal to 36 divided by 3.6, which is 10 amperes. So if you are doing all these calculations to figure out the current IS, yes, you can do it. You can use the nodal analysis and then figure things out from there. But don't you consider that this entire process was a little more difficult than the thing over here where you had recognized that this is forming a Wheatstone bridge and I can simply eliminate this particular thing, and then I can solve this equation to figure out the current as 10 ampere. It took me hardly 2 minutes to figure this out, right? If I understood that this is a Wheatstone bridge, compared to the 10 minutes I spent for solving the nodal analysis, right? So I think if you are able to recognize things and then based on that deduction proceed forward, it will save you some time, right? Which will be helpful in your examinations, right? Where you have a time constraint. Am I clear to you, Prashant?
Yes, sir. Yes, sir. Yes, sir.
Right. So this is how you are solving question number 3. Let me now go on to question number 4. So I think I have run out of time. The second session would have already started, right? So I'll have to end this meet now. So I'll just quickly tell you like question number 4 and then I'll end this meet, right? You can join the second link and then the other TA will be taking it up now from there. So in this particular circuit, you are asked to evaluate the potential V0, which is across this particular I0. So let me ask you a very theoretical and a very fundamental question. What voltages can be applied across a current source? Can you apply any voltage across a current source, theoretically speaking? Let me ask you another question. What current can be given out by an ideal voltage source? So if you have, let's say, a 10 volt voltage source, ideal voltage source, what is the maximum current which it can give? Ideal voltage source.
0.
Maximum, I'm saying. That is the minimum. You are correct. It's the 0 is the minimum current it can give. What is the maximum current it can give? Infinite, right? There is, if a battery is ideal, there is no limitation on what like there is no internal resistance, there is no limitation. So basically, it can give you an infinite current, right? Theoretically speaking, not practically, theoretically speaking, right? Am I right, guys? Okay, nobody is responding, but then that is the meaning of an ideal thing. You can have practically, practically you can have a limitation that the battery can give you a 10 ampere thing at 10 volt. Let's say this is your particular rating of the battery. After this, there will be a dip in the voltage. So the voltage will dip to 9.8 at 11 ampere, let's suppose. But for an ideal battery, there is no such limitation. You can have any value of current. You can have 10 amperes, 100 ampere, 10 volt, 100 ampere. You can have 10 volt or any X ampere, right? X can be anything. Similarly, for a current source, you can have, let's say the current source value is 2 amperes, right? So at 2 amperes, 10 volt can be impressed across it. At 2 amperes, minus 10 volt can be impressed across it. At 2 amperes, any X amount of voltage can be impressed across it. There is no such limitation. So ideal voltage source, ideal current source, this is how you define them, right? But in practical life, things are different. So I just introduced you here to the ideal concept, right? Now this here is an ideal circuit. So the voltage across I0 can be anything, right? Whatever comes out to be the voltage, that will be the voltage. So you have 30 volt with you, right? And 7 amperes current is flowing out from here. So you can write the potential at this point A, B. So VA is nothing but 30 volt minus 7 into 2, right? 7 amperes into 2 is VA, right? So this will be equal to 16, correct? So this is VA. How about VB? So I know that if VA is 16 volts, then current flowing in here will be VA I, let's say call I. So current I will be equal to I VA divided by 8 ohms, correct? So this is nothing but 2 amperes. So 2 amperes flows in here, correct? So incoming current was 7 amperes. So what is left? 5 amperes, right? And if 5 ampere current flows in there, then I can write VB as VA minus current in 2 ohms load into 2 ohms, right? So I know that current in 2 ohms is 5 ampere. So I can write that, and I also know that VA is nothing but 16 volts. So I can write 16 minus 5 ampere into 2, that is 6 volt, correct? Now if I have this, what is this? This is nothing but VB, right? I have just calculated this. So VB is nothing but 6 volt. Now if I have the value of VB as 6 volt, the current here is going to be 6 divided by 1, that is 6 ampere, right? So the incoming current is 5 ampere, the outgoing current here is 6 ampere, therefore there must be some other incoming current of 1 ampere magnitude, right? Right guys? Because the KCL must be followed, right? So at this node, you can write the KCL. So 5 ampere current is coming in, 6 ampere current is going out, therefore 1 ampere current must be coming in. So that must be the value of I naught, because that is the value of current which is coming in. Now, if you have the current which is coming in it as 1 ampere, then the voltage drop across this 3 ohm will be nothing but 3 ohm into 1 ampere, that is 3 volt. Correct guys? And if the question asks you what is the potential across this particular thing, you can write that V naught plus I 3 ohm into 3 ohm is nothing but VB. But I know the value of VB. This is nothing but 6, right? And I have written here, sorry, minus aega. So V naught minus IR, right? Because this is, I am moving in the direction of flow of current, right? So V naught minus I 3 ohm into 3 ohm is equals to VB, that is 6 ohm. So you just multiply this. What is I 3 ohm? It is 1 ampere. So 1 into 3 is 3. And then on the right hand side, if you will take it, it will become plus 3. So it will be 6 plus 3, which will be equal to 9. So V naught will be equal to 9. So if V naught is 9, just see the thing. It is here over here, right? So D becomes your correct answer. So the idea over here is that you just need to like go with the flow of the circuit here. So you take the circuit, you know, you proceed with what is known to you. So what is known to you is 7 amperes. What is known to you is 30 amperes. What is asked of you is something which is unknown, right? That is V naught. So for that, you just have to proceed with the known thing and then use the knowledge of your basic KCL and KVL and then proceed on from there to get the answer. So have I made myself clear in question number 4? Guys, just respond. Okay. Somebody has raised. Please feel free to give your. Please feel free unmute yourself and then ask. Unmute yourself and ask. Okay. If all of you have understood that, then I'll end this session because the time has also ended, and you can join the other session, which will be which would have commenced, and then. The other TA would be helping you out with the other questions in this particular assignment, right? So any feedback which you guys would want me to give, which you guys would want me to know, like please feel free to give your feedbacks. So Danish Hassan Khan, do you have any feedback for me?
Yes, sir. No, sir.
Okay, did
It's
you
all right, sir.
understand everything which I covered today, Danish?
But in the last some 1 ampere, where is it from 1 ampere? I don't know, sir. I
Okay,
can't get it.
1 ampere. This you are saying, right? Here, Danish?
Yes, sir, correct, sir.
Right. So 5 ampere current is flowing in, 6 ampere current is flowing out. So what current must be flowing in from this section?
Oh, okay, sir, got it, sir.
Understood, Danish?
Yes, sir. KCL model.
Right. So use the basic KCL and KVL and everything can be done. Or the only thing which I'll recommend to you guys is solve a lot of problems, right? And then things will become easier and much more relevant to you guys. Okay. Thank you all for coming. It was good talking to you all guys. Shall meet you again next week. Till then, take care. And this is the end for today's lecture. Bye bye.
Thank you, sir. Bye, sir.